everyone. Welcome back to Learning at 11th Hour. Today we are going to talk about superposition theorem. As the name suggests, we are going to perform some superimposition. But why do we really need to use it? So let's look at the statement for this theorem first, and then let's look at a simple problem to understand this theorem. So the statement says a linear network which contains two or more independent sources can be analyzed to obtain the various voltages and branch currents by allowing the sources to act one at a time and then superimposing the results. Which means what? So let's look at this example. Say we need to compute the current going through the 23 ohm resistor. Now, what we are going to do here is we are going to observe that there are two sources here. One is a voltage source, which is 200 volts. The other is the current source, which is the 20 amps. So now there are two sources. They say that we can compute the effect of or the current due to one source acting at a time, ignoring the other source, and then superimpose their values. For example, first let me ignore this 200 volts voltage source, and the 20 amps alone is acting. For example, let me assume. So, what is the current due to the 20 amps current source? Let me call it as I1. Now, in the second case, I'm going to ignore the 20 amp current source and find the effect of the 200 volts voltage source on the 23 ohms resistor. So, say the current due to that is I2. Then the total current I flowing through the 23 ohms resistor would be given as I is equal to the effect of 20 amps current source acting alone, which is I1, and the current due to the 200 volts source acting alone, which is I2. So I have now superimposed the effect of both the voltage sources, assuming that they were acting independently initially. So how can I do that? In this case, first, let's analyze the sources, right? So if it's a current source, we need to open circuit it, whereas if it's a voltage source, it should be shorted. So case 1, let me consider that only the 200 volts uh, voltage source is present. So the 20 amps is not there, which means what? I need to open circuit this. So let me redraw the circuit. So here I'll have the 27 ohms. I'll have the 47 ohms here with the 200 volts voltage source acting. Then I have the 4 ohms here and the 23 ohms through which I need to compute the current. So see, we have conveniently open circuited the current source over here now. I need to compute the current flowing through 23 ohms, which will now in this case be I1, right? The current due to the 200 volts voltage source, whereas I2 was the current due to the 20 amps current source. So how do I compute this? Here I can apply simple loop analysis, or I can compute the equivalent resistance of this entire circuit and then find out I, and then I can use current division and find out the current through the 23 ohms resistor. So let me follow the second approach. So if we observe, we see that the 4 and the 23 are in series, which is in parallel with the 27 ohms. So what I have here is I'll keep the 47 ohms as it is with the 200 volts. So this is just simplifying. I can use any method to simplify. Since we haven't discussed this, let me go ahead with it. So the 4 and the 23 are in series. If you see, the same current is going to pass through both 4 and 23 and come back. So that means they are going to get added the resistances. So that would be 27 ohms. This branch is this branch. Now, this 27 ohms is also in parallel with these two resistors because they are connected across the same terminals X and Y. So I can write this as 27 ohms too. So now these two 27 ohms are in parallel with each other. So 1 by 27 plus 1 by 27 the whole inverse, which is 27 divided by 2. So I can redraw this again as 47 in series with 27 by 2 ohms, and I have the 200 volts source connected here. So the total equivalent resistance of this circuit becomes 47 plus 27 by 2 ohms. So having found this out, I can find out the total current I in the circuit as 200 divided by R equivalent. The value of R equivalent can be found out to be 60.5 ohms, and therefore the value of I can be found out to be 3.31 amps. Now let's look at this circuit. Okay, so what we need to find out is we need to find out. So let me split this up again for simplicity. So this is going to be the 4 ohms, and this is my 23 ohms again, right? So I've split it up so that I'm able to find out the current through this 23 ohms. So if I'm able to find out this total current I, which I have right over here, then it is splitting up into two. So in one of the branches, I have 27 ohms. In the other branch also, I have 27 ohms. So basically, we can intuitively say that the current is going to get divided into two. So 3.31 divided by 2 amps will be the current which is flowing through the 23 ohms resistor. I can either say that. So this would be my current I1, right? Because this is the current due to the 200 volts voltage source. So I can either find it out like that intuitively, or I can apply the current division rule. So here the total current is 3.31. The opposite resistance. So I need to find out the current through the 23 ohms. So the opposite resistance in this parallel connection, right, is the 27 ohms. So opposite resistance divided by the sum of resistances. So since both of them are in series, I'm going to say 27 plus 4 plus 23, which is 27, sum of all the resistances, right? So this again turns out to be 3.31 divided by 2, which is 1.65 amps. So this is my I1. Let me now compute I2. So in order to do that, I am going to consider only the 20 amps current source, and I'm going to ignore the 200 volts. Now this is a voltage source. So the voltage source has to be short circuited, and then I'm going to find out the effect of the 20 amps current source in the entire circuit. So let's see how this is done. Let me first redraw the circuit without the voltage source. So I'm going to have the 27 ohms intact, and I'm going to have this 47 ohms. This 200 volt is short circuited. I'm going to retain the 4 ohms here. The 20 amps is going to look like that. This is the 23 ohms resistor. So now here clearly we can see that this is a total current of this circuit, and it is splitting up into two branches. One of it is entering the 23 ohms, which will be I2, right, which I need to compute. So the effect on 23 ohms because of 20 amps, which was I2. And the other one is the current which is going to go into this branch and then split up from here. So these are the two branches that it splits up into. So if I am able to apply current division rule over here, what I need to do here is I need to find out the total resistance of this part of my circuit. Let me call it as say R. So how do I compute R? So if I see the 47 ohms and the 27 ohms are connected across the points AB, which means they are parallel to each other. So therefore, that can be written as 27 into 47 divided by 27 plus 47. So this is the resistance of these two branches put together. This is now in series with the 4 ohms resistance, because this current is going to go into 4 ohms and then it is going to split up between 27 and 47. So 27, 47 are in parallel, And both of these, this combination, the parallel combination, is in series with a 4 ohms. So I'll say plus 4. So this entire thing is equal to R. So this is my opposite resistance. Opposite to what? It is opposite to 23 ohms, because I can actually redraw this as, this is say 20 amps. I'll have this R, which I just found out over here, and I have the 23 ohms over here. So now I can compute the current I2 as, I2 is equal to the total current 20 into opposite resistance, opposite to the 23 ohms, which is R, divided by the sum of resistances. So 23 plus R. Here, the value of R is found out to be equal to 21.15 ohms. So now if I replace the value over here, I will obtain my I2 as 20 into 21.15 divided by 23 plus 21.15, which turns out to be 9.58 amps. So now we have obtained the value of I1 as 1.65 and the value of I2 as 9.58 amps. So what was I1? I1 was due to the 200 volts acting alone, passing through the 23 ohms, and I2 is the current passing through 23 ohms considering only 20 amps is acting alone, ignoring 200 volts. So the total current in the 23 ohms resistor can therefore be obtained as I1 plus I2, superimposing both the effects. So that turns out to be equal to 11.23 amps. So we can now verify this, right? We can actually go for some other analysis methods. We can go for maybe even Thevenin's or Norton's theorems. We can go for nodal voltage method or mesh current method. And we can find out I through 23 ohms. If you're going for the mesh current method, you have to go for the super mesh because there's a current source between the two loops, loop 2 and loop 3, the middle loop and the rightmost loop. So you can do that as a small exercise and then you can let me know if you have any queries. So that's all with today's video. So I hope you've understood the concept of superposition theorem. We'll come up with more such problems in future. So just a few things that you need to note. One is that you can not apply this in case of dependent sources if uh, the quantity that it is dependent on is lying in an external circuit. So because see, we are going to ignore one particular source completely. So when we do that, if the effect of that lies external to that particular source, then we are not going to be able to apply it. It will not be valid at all. Secondly, this is applicable because the current and the voltage have a linear relationship. So we cannot directly apply this to compute the power because power is having a non-linear relationship with the current and voltage, because the power is I square R or V square by R. So that leads to a non-linear relationship. So these are a few trivial points which you can keep in mind when you go for superposition theorem. Thanks for watching. Please do subscribe to my channel.